Every so often I come down to this park where we've got our holiday home. It's an ideal place to try out antennas because there's plenty of open space. I wanted to try out a random wire antenna. I've used a 9-to-1 UnUn in the past but never been terribly happy, so I thought I'd try something a bit different, perhaps with more efficiency. Well, hello once again, and thank you for joining me on the Waters and Stanton video channel. I'm going to talk bits about the 9-to-1 UnUn, but then move on to something I call the floating ATU. Curious name, isn't it? But anyway, if you follow me, you may well find out why I call it the floating ATU. Well, let me first of all say that I've been using a 9-to-1 UnUn on and off over the last 2 or 3 years, but I've never really been happy with it. Now, I know that many hams use them and are delighted with them, but I haven't found it to be quite what I expected it to be. So let me first of all tell you my experience with the 9-to-1 UnUn, and then perhaps give you an alternative that may actually work a lot better. Not under all circumstances, of course. Anyway, let me tell you my experience first of all with the 9-to-1 UnUn. A 9-to-9 UnUn is basically a transformer, an RF transformer. It's got a ratio of 9-to-1. And the theory is that if you were to feed it with an area which presented a 450 ohm impedance, then it would transfer it down to 50 ohms, which is ideal for transceivers, because our transceivers are 50 ohms. Why 450 ohms? Well, it's an arbitrary figure, really. But the basic idea is that it's used for what we call a non-resonant aerial. In other words, an aerial that is neither a half wave or a quarter wave or multiples thereof on a particular frequency. So provided that that length of wire that you have doesn't represent a half wave or a quarter wave or multiples thereof, then it's what we call non-resonant. And the idea is that if an aerial is non-resonant, we can actually adjust it so it presents a sort of medium impedance, 450 ohms. That's the ideal. But it doesn't really translate in the real world. There are a number of reasons why it doesn't translate, but it's particularly difficult to actually get it to work properly if you're using fairly short lengths of wire. And I noticed that all the commercial designs have lengths of wire which are around about 70, 80, 90 feet. And there's a disagreement as what actually a non-resonant aerial, or what the ideal non-resonant length is. And of course that non-resonant length will also depend on the height of that wire is above the ground and so forth. So the 9-to-1 UnUn should be great for a non-resonant antenna, provided it presents about a 450 ohm impedance. Well, for whatever reason, it very often doesn't. As I said, the most successful use of a 9-to-1 UnUn seems to be in longer lengths of wire. And of course, also the idea of the 9-to-1 UnUn and the non-resonant aerial is that it will be resonant, or it will be non-resonant on a lot of frequencies, and therefore a lot of frequencies it will represent a medium impedance. That's probably why longer lengths of wire tend to work better than shorter lengths. But for my own personal use, for portable work, I actually don't want a long length of wire. I want something a bit shorter. Maybe that's why I find that the 9-to-1 doesn't really work for me. It's very easy to build. I'll show you a couple of shots here of a 9-to-1 UnUn that I made. I won't get any prizes for construction. And I've used some fairly thin wire to do the windings because I wanted it just for low power work for around about 5 or 10 watts. And it will handle that quite easily. I used a 240-43 mix Farad core, and I did check it with a 450 ohm load, and it works quite well. Typically you'll get a VSWR around about 1.2, 1.3 to 1. But as I said, it doesn't translate that into the real world, because in the real world, when you try and use it with a shortish length of non-resonant wire, you get a VSWR indication somewhat higher, and looking through all the various magazines and looking at YouTube channels and so forth, invariably the operator ends up also using an antenna matching unit, very often the one that's in the transceiver. But to some extent, if you have to use an antenna matching unit, you question, well, why do you want the 9-to-1 really? Maybe it just brings the impedance down to a low level so the transceiver can match it. But I really don't find that terribly satisfactory.
Here's a sketch of a short length of wire with a 9-to-1 UnUn that I've used in the past. The 29 foot is one of the lengths that is recommended as a non-resonant length of antenna, and really and truly I would have expected that to work on the 20, 17, 15, 12 and 10 metre bands, or some of those bands, and it did, but I could never get a reasonable VSWR. I always had to use the internal transmatch of the transceiver. But the internal ATU of a transceiver has its limitations, so here I've replaced the 9-to-1 UnUn with a LFG Z100 antenna tuning unit, which benefits from an internal battery supply. This makes the system much more versatile. Let me first of all show you the Z100 very briefly. Tuning from the front panel is very simple. You inject 2 or 3 watts of RF power, press the button in, light will come on, and the ATU will tune itself within a few seconds. On the back you've got input and output SO239 sockets. I've fitted an adapter so I can connect wire to it. There's also an external DC socket and an interface socket for your transceiver. One of the big advantages of this tuner is that it'll run off internal AA cells, so you don't need an external supply. And those batteries last for ages because the relays are latching. They only draw current whilst tuning.
I use the Z100 with my Icom IC705 and it works wonderfully well. The interface socket on the Z100 is a 3.5mm stereo socket, and the Icom IC705 has an ATU interface which also has a 3.5mm stereo socket. So all you need is a lead with 3.5mm stereo plugs either end, and you can get some fairly long ones from any sort of musical retailer or Amazon, etc, etc. So it's very easy to hook this Z100 up to an IC705, and then it is totally automatic. You can press the tune button on the Icom radio, or when you change frequency and the ATU senses that the VSWR has gone up, it will automatically tune. It's that simple.
Now, of course, there are going to be situations where you can't substitute your 9-to-1 UnUn for the ATU, but they are few and far between, particularly if you're out portable. And so I think that if we're talking about portable operation particularly, then the 9-to-1 UnUn can, generally speaking, be substituted. I know there'll be exceptions, but generally speaking, you can substitute the 9-to-1 UnUn for the ATU. Now, the IC705 is a great radio, but as it's been well published, it doesn't have an internal antenna matcher. And therefore, in many respects, it's not a very good radio to use with a 9-to-1 UnUn, because, as I've outlined before, you're unlikely to get a low VSWR on more than perhaps 1 or 2 bands, if on any bands, particularly when using a short antenna. Let me take you back to a clip from a video I did on the W3EDP antenna and see if we can actually make use of this principle for our portable operation. To survive. So I'm going to put up on the screen here the original layout of the W3EDP antenna. Now, as you can see, it's 84 foot of wire fed with an ATU or an antenna matching unit, and it's got a counterpoise of 17 foot.
So perhaps you can see where I'm going on this, because that antenna required an antenna matching unit, and that matching unit was inserted near the end of the antenna. Now, I grant you that was a much longer antenna and it covered 80 metres through to 10 metres, but we can use that principle for covering perhaps some of the higher bands. Let me now take you to the T2LT antenna, which also has an interesting capability, and I think we might be able to match these two principles together to make a third antenna.
Here's the basics of the T2LT antenna. It's a single band antenna, and you've got a quarter wave of wire going vertically, and you've got a quarter wavelength of coax cable coming down to a choke, an RF choke or an RF isolator. So the total length is actually a half wave. You've got the upper length of the antenna, quarter wave, the lower length of the antenna, so quarter wave makes it a half wave. And because RF actually flows on the surface of sheathing, RF is allowed to flow on the outside of that sheathing to form what is basically a vertical dipole. And we need that choke at the bottom to choke it off so that the whole system resonates as a half-wave dipole. And half of that dipole is comprised of the coax cable feeder.
So let's now combine those two ideas into one single antenna and see what we come up with.
Well, effectively, it's very much like the W3EDP antenna. We've got on the right-hand side a long length of wire, which is the main radiator. We've got the matching unit, which effectively is the LFG ATU. And then we've got the counterpoise, which is formed because we've choked off the coax at the point at which it connects to the transceiver, but the sheathing will actually radiate. So we've got a W3EDP antenna. Now, I've purposely not put in any measurements because the fact that we're using an antenna matching unit means to say that we've got great flexibility. But you could maintain the relationship as per the W3EDP antenna, and that would give you 80 meters through to 10 meters, but you can halve these dimensions, which will give you 40 through to 10, etc, etc. In my particular case, I had a length of 29 feet on the main element, and then I had about 2 meters, sorry, we're mixing the measurements up, about 2 meters of coax cable from the ATU back to the transceiver. So the measurements I've used aren't directly proportional to the W3EDP, but that doesn't really matter too much.
One of the issues with the 9-to-1 UnUn, of course, is if there's a fairly serious mismatch, there's likely to be some significant heating of the ferrite material, and that might well add to losses. But the only way you can really check that is to run some power into it and then check it for heat, which means you've got to take the casing off if you can get to it. So another good reason not to use a 9-to-1 UnUn if there's an alternative. Anyway, let me show you the antenna system that I used when I was away recently at the holiday park. Unfortunately, I forgot to take my power supply, so the only supply I had was the internal battery on the IC705, so 5 watts was my maximum power. But it was an interesting experiment, an interesting session. Let me show you.
One of the essential parts of this antenna system is the line isolator there. That actually really becomes the end of the aerial because the outer of the coax cable is acting as a counterpoise. As well as the coax coming from the radio, I've got this control wire here. This is a control wire that goes along here, and it goes to the ATU, which is balanced on the window ledge here, as you can see. And the antenna cable is there. It just goes through the jamb in the window. And there's the wire coming through the window. There's now a shot of the aerial. Actually, the camera makes those power wires look as if they're near the aerial, but they're not nearly as near as you would imagine. And they're perfectly quiet, so whatever they're doing, they're not causing me any problems. One thing, or one problem I had, with the wind, it's got quite windy, and the mast here, which I'll just show you on the other side of the camera, the mast here was getting a bit wobbly. Well, not wobbly, but it's sloping a bit, and I really didn't have enough lashing to make it secure. So I decided to change the arrangement. I've run the wire straight down the mast. It is roughly about 16 foot, so it's about a quarter wave on 20 metres. And then I run this wire along here and taken it back through the window here. Bit of a compromise, of course, but I do enjoy making the best of what I've got when I've left things at home. A simple 3.5 to 3.5 millimetre lead connecting the Icom to the LDG makes tuning very, very simple indeed, and it only takes seconds. This is the early morning results on 20 metres calling CQ on the QRP frequency on 20 metres, which is 14.060. The band wasn't really open, but I was spotted by quite a few stations over a 5-minute period. And the signal reports are quite good. Some are about 12 or 15 dB above noise, so that's quite encouraging. And all from a very simple wire antenna operating from my holiday home here in Suffolk. Well, there we are. That's the floating ATU, or the floating antenna matcher. It works extremely well. I've used it on previous occasions. It gives you a very flexible antenna system. The antenna will work on all bands depending on the length of the antenna. On this particular one, the performance I got was great on 40 through to 10 metres, no problems at all. It matched on all bands with ease. If you want to go on to the lower bands like 80 metres or 60 metres, then you will need a longer length of wire. But you don't need it too long. It's quite a flexible system for a compact portable operation. And I was very, very impressed with it. It was nice to see a really good match on any band. Now, where does that leave us with the 9-to-1 UnUn? Well, I've had, as I said at the beginning, a love-hate relationship with it. I find that it's not particularly good with short antennas, and invariably you do need the use of the internal antenna tuning unit in your transceiver. It seems to work better on longer lengths of wire, but even then the benefit of an internal antenna tuner is very much required. And that means to say that there's not a particularly good match to the 9-to-1 UnUn, which in turn means that there could be some losses, particularly at the higher powers. So the 9-to-1 UnUn in theory is a good idea. The problem is that you can't always, and very often can't, achieve a decent match that enables the 9-to-1 UnUn to be used without an antenna tuner. Now, I'm sure there'll be many out there that say, oh, well, I've managed with this and I've managed with that and it's fine. Great, if it works for you. But, as I say, generally speaking, I find you need the benefit of an internal antenna tuner. With this system, I grant you, it's not for everybody. Not everybody will find this floating ATU useful or practical in their particular circumstances. But if you can accommodate it, I think you'll be impressed. I was. Don't forget that if you're looking for an LBG antenna tuner, or in fact any other ham radio product, check our website. And we've got a complete range of ham radio gear. We've got over 4,000 items in stock, believe it or not. And if you're in striking distance, because we're close to the M1, please pay us a visit. If you can't pay us a visit, then of course you can use our internet ordering system. If you've got any queries, pick up the telephone, speak to one of our guys. We're always happy to help you. In the meantime, thank you for your support on this channel. It's much appreciated. Thank you for your support at the shop. And you enjoy your ham radio. And as usual, I look forward to seeing you in the next video. Bye for now.